Good afternoon, everybody, or good morning, or good evening. Welcome to a new webinar. It's been a while since we've done one, but it was more than due time to start a new one. We're here in another part of our demo room. This is what we call the laser area, and I've brought my lovely assistant here because today, by the way, she's called Lena. We're going to talk about garments and where laser technology will, let's say, impact your production in terms of garment cutting. If we look at my assistant here, she's wearing a dye sublimated piece of textile. It's been dye sublimated, then sewn, and in the end, you have your finished product. So laser itself does cut many textiles. It does give a lot of advantages, especially on the synthetical textiles. If you look at synthetic textiles, especially the dye sublimated textiles, one of the major advantages that we provide is that the edges of the materials get sealed. So this advantage that we have with the laser, where the edges are sealed compared to standard knife cutting, is that it's going to be easier to transport from cutting to sewing without having the material fray. If we look at several cut pieces that I did recently, you will see if I start pulling the edge, there's no fraying going on at all. So your pieces stay intact until they are sewn in. Now, looking at the complete textile workflow, we need to look at several things. First of all, it is printed material, so you start out with white material, and then you need to put on prints, and then you need to, let's say, develop a way of cutting the shapes. There are several possibilities there, but we have developed, or we are using a very user-friendly system called Vision Trace. More on that a bit later, because I first want to, let's say, focus on how the jobs are created. For this, because we are not workflow specialists in terms of creating software to automate these nests, to automate the, let's say, the complete patterns. We've worked together with a company. It's a small company, but they do generate a very nice piece of software. It's a company called L1810 Vision. They're based in Israel, but what I've seen and what I've experienced when using and looking at their software is that it's a very powerful piece of software. And well, I'm not going to explain it because Guy Alroy, who's the managing director or the CEO of the company, is more capable than me to explain this. So I would suggest that we go over to Guy, and he's going to explain the piece of software L1810 Vision to all of you. So let's go over to.
Thanks, Randy, and thanks for inviting us for this webinar. A little intro about L1810 Vision, and we'll jump right into the scenario. L1810 Vision is a software company that focuses on solutions for the digital textile printing, with a vision of reducing the pollution that this industry is generating. And we believe that this will be done only when the industry will move to on-demand. We support our customers in multiple scenarios. Our focus for today is the all-over print, print placement, print, cut, and sew. But we also have solutions for automating fabric orders from e-commerce all the way to the printer, and for DTG. The session that we'll focus on today is an example of how you handle all-over print. In terms of challenges that we are hearing from our prospects or from our customers before they implemented the system, it's all about scale. They want to scale, but they want to know that if they acquire additional printer and cutter, they don't need another group of employees to handle it. They want to serve brands, but if every engagement is too complicated, then it's not scalable. They want to engage with personalization, but if a graphics guy has to touch each one of them, it's not scalable. And they want to offer their services on demand to merchandising sites and other B2B partners, but again, in a scalable manner. In terms of the design tools, so not all authoring is done in the same manner, right? A consumer cannot see 2D interface. He must see a 3D interface online in a browser. An internal designer usually will use tools such as Adobe Illustrator, and we know to acquire the designs done through there. An external designer might use also Illustrator, but we also offer our customers a way to get designs from them in 2D and 3D. And the professional designer, in most of the cases, is using Adobe Illustrator. These are tools that the brands is forcing them to use, and a whole workflow done around them. Now let's look a little bit about the workflow that we'll see later. Consumer goes into the e-commerce site, yours or your partner's site, and orders a predefined design. A brand is submitting a design and then an order for that design to be produced on demand. And maybe also a consumer that is personalizing an item and submits an order. All those orders at the end of the day are aggregated in the e-commerce or in your ERP. Whether those are singular items or hundreds of items, it doesn't really matter. The Early Vision backend will connect to those sources, get the items, group and split them by materials, by technology, by ink, and so on, and prepare the needed files in a nested manner for the printer and for the cutter. When we say nesting, we mean garment nesting that understands buffer, grain direction, pieces, and so on. Here we can see a result, different designs placed together. Here it's even different garments placed together on one sheet because they are all printed on the same material. 3D customizer online, 2D and 3D customizer online. We'll see that live in a second. These are some examples of what our customers are making with this, and the Illustrator integration that we'll see as well very shortly with the 3D embedded viewer, and the output again to the printer and to the cutter. Similar automation for DTG, different challenges, different workflow, but we have customers that do both DTG and all over print, and then also for fabric orders as well. Our focus today, all over print. Let's jump right into it. So what we see here is a website, an e-commerce site implemented on WooCommerce. We have a similar set of tools for PrestaShop and for Shopify, and we also offer our online editors through APIs. The structure of this site is similar to what we see within our customer base. They offer predefined designs and also personalization. Here we jump right into one of the leggings, pick size L, set the quantities and add to the cart. So far it's the regular WooCommerce scenario. Then going back to the leggings, we'll pick now the personalized one and ask to customize it. So I pick the size, and our integration into WooCommerce will replace the Add to Cart button with Customize. So as soon as the user clicks on Customize, he will get, in this case, the 3D interface to personalize these leggings. A similar interface exists in 2D. We'll do something very simple in this session. Upload a repeating tile. We'll not spread it first of all. We'll set the size properly, repeat it, and then use it on the pieces we wish the repeat to appear. Let's put it on the yoke as well. And for the waistband, we actually want to pick a color, this purple color, from the repeating tile itself. Now, the Add to Cart button here, due to our integration into the e-commerce system, again, in this case, WooCommerce, is packaging the design so that it can be manufactured on the back end, but pushes the line item into the shopping cart. So now we have the predefined design in 2 units and 1 unit of the customized design. And let's proceed for checkout and place the order. That's basically the online scenario. Now let's couple that with the designer scenario. We said most of the designers are using Adobe tools, Illustrator, and InDesign. We are here doing operations that are pure Illustrator, placing 2 logos on the waistband, centralizing them, and so on and so forth. But then the early vision embedded 3D viewer allows me to see how it looks in real scale, both the repeating size, how it meets over stitches, and the placement and the size of the logos. The next tool is to package this, is to briefcase this design into a nested ready file. In this case, we just pick size M. This prepares the file so that the nesting engine can handle it. And then you can even, from within Illustrator, we request a job, specify job parameters, but also specify the quantities per items that you ask on this job. So the first one is this item we just created, and the second one is another design of the legging, and we'll ask for 2 units of that in size small. Now let's go to the backend. On the backend, we said we had an order from online and we have an order from a designer. So the first step is to download the orders. Usually this is done automatically during the night or at scheduled times during the day. Here I'm doing it manually so we can control each step. When I download, we will see at the upper right corner an EVI file, which is the order information file that was generated from the order we did on WooCommerce. Now we will ask to merge that and process it together with the order that we got from the designer. Now, given that all the designs that we did here were the legging, it's the same material and everything can fit into just one merged file. But if it's done from multiple materials, the system automatically knows to segment and split the orders by material and send them for nesting. The nesting, how much time you spend on it, here we are doing something like 1 or 2 minutes. In reality, you can do a little bit more depending on the cost of the material. But even with 1 or 2 minutes, you see 20-25% savings in fabric orders. And that's the result. A nested job ready for print and cut with QR codes and the right bundles around them. So again, the workflow, different sources of orders can be from different sites, merged into a nested sheet that is sent to the printer and to the cutter. Randi, back to you.
Thank you, Guy. So as you can see, let's say dedicated companies like Early Vision offer very brilliant pieces of software to, let's say, generate that output that you can send over to your printer. Now, again, for this webinar, we've cooperated with Early Vision, but we've also cooperated with a customer, actually a customer of Early Vision and of Summa, because this customer, who's located in Croatia, did some printing for us, so the dye sublimation printing, and he's using the Early Vision software, but he's also using our laser systems. He currently has a older laser system to cut a lot of his textile before it's being printed. So in this, let's say, post-print cutting system, We're using a vision system. But before we go to that, let's go over to Caspar. Yeah, Caspar is the company in Croatia, run by a guy named Ziggy, nice guy, who was very willing to help us. So let's first look at his company, because it's a very nice company, very clean company, very structured company. So let's go over to... Okay, so Caspar, nice company to see, with very enthusiastic people working there, especially very enthusiastic about their national football team, as you could see from the video. You could briefly see one of our lasers running. It is a laser not similar to this one. It is a laser without the vision system. Now, that's what we're going to do now, because we've saw the creation of the files. We saw a company that was printing textiles, and now we need to cut them, because it's going to be difficult if you have a complete roll of fabric to start sewing this. So we generally need to look at the way that the company is going to, let's say, print their media, because we have post-printing and we have post-cut printing, and we have pre-cut printing. So pre-cut printing is generally you print a complete roll, and that roll is going to be cut afterwards. Post-cut printing is generally multiply, where people will layer up their different kinds of fabrics and then start to cut, generally manually or with a cutting machine, to generate a lot of the same patterns, and then they are going to print these individual patterns. Now, what we are going to do, especially with our laser system with vision, is we're going to do all those pre-cut printing processes. So in general, we start out with a roll, and on that roll we have all the patterns, all the shapes that need to be cut. How do we cut those? Generally, you look at two systems. One is using registration marks, which are references being printed on your material. Generally, these are circles or squares that indicate where everything should be located. Now, the difficulty here, the challenge here is you have files that you need to open and use with those kinds of jobs. If you use registration marks, it's going to take some time to always open up the correct file, to read all those registration marks, and then indeed cut everything to the exact on the exact position and the exact shape. What we've done, especially on our L1810 Vision, is where we have a top head camera, and that top head camera is able to scan a certain area of the working bed. By scanning this area, our software is able to generate those contours by itself. So you don't need to open up a file. It's our software that will generate on the fly the cut data. So it scans, analyzes the image, and then it starts to cut. Now, what we do need for this is a black outline around each shape. Why? Well, if you have a, let's say, a white garment piece where you only have a small logo on, you need to have a black outline, because white on white material is going to be difficult to recognize where everything is. So the only prerequisite here is to have a black outline, about 2 or 3 millimeter in general. By adding the black outline, our software will scan, detect it, and then you're able to cut it. Now, there is certain influence you can do. You can either cut on the outside of the black line or on the inside of the black line. This is a personal preference. A lot of people will cut on the outside or in the black line to use a hem cut sewing machine. If you don't use hem cut sewing machines, then generally they cut on the inside of the black line. But that's purely up to personal preference. Now, in our system here, we're going to look at the machine cutting. I'm not going to run the machine live, not because I don't want to. It's just simply the machine uses a air extraction, because when you're laser cutting, you generate fumes, and all these fumes need to be transported. Also, there is a fire alarm here. So what we don't want is to have the alarm activated when we do not switch on the extraction. So the extraction is quite loud here. It's a smaller room, so it generates a bit of noise. So I would be needed to raise my voice during the running of the machine. So I did pre-record everything. Everything that I've cut is here. This was generated from all those designs that were printed. So it's sewn and it's on our Lena here. So before I explain further, let's briefly look at the initial startup of a cut piece. So if we can run the video for the first. So I would just suggest for everybody to just briefly look at the video, and then I'm going to explain a couple of things. It is a short video, it only takes a minute, but it does show a couple of things that I would like to put my finger on that, let's say, separates us from any competition or separates us from any thing here. I know the video was silent because I didn't want to record any of the extraction noises. So one of the things that you should have seen, we will start the rest of the video. I'm not going to run the complete, let's say, the complete video of the complete roll. I will start up let's say, a section of it, and then you can look at it. One of the things that you should have noticed is that while the media is being transported, the material is already being cut. This is basically also one of the benefits of laser cutting. If you cut with a knife, you're generally pushing on your fabric, and you're going to move around your fabric. If you're transporting your fabric, there's no chance of, let's say, holding down your textile. There's no chance of creating a vacuum, because you need to move your material, vacuum it down, and then start to cut. With the laser, because laser is non-contact cutting, it generally moves the fabric, and while it's moving, it's able to cut it without moving the fabric around. So there is no, let's say, interaction on the fabric. That leaves us also the possibility of let me show, yeah, let me just grab this. If you look at this fabric, it is quite stretchy in a lot of directions. Oh, sorry. It's quite stretchy. So if you use a knife, you're going to stretch that fabric while you're cutting. With a laser, that doesn't happen. If you use a knife, you generally are going to cut, let's say, very low stretch or non-stretch materials. Here, with a laser, we can easily cut any kinds of lycras, even swimwear, which is quite big in stretch value. So that's one thing that we notice. The other one is, if you look at the bottom right of the screen, is the scan area. So you will see an area that is being scanned, and immediately the cut file is generated. So we do not open a cut file, we simply press scan, then cut. So while it's continuously scanning, so it's scanning segment per segment, it's going to generate those cut lines and will cut in the correct path. The only setup you need to do there is contrast values, your edges, and how much inside the black line you need to cut. Basically, anywhere from 0 to 3 millimeters is something we allow. Looking further, is you could see in the beginning a cut from left to right along the complete width of the material. Well, this cut is what we call waste cut. It's something that is automatically generated by our system. There are a couple of reasons why we do this. First of all, we know material, textile, is stretchy, can be heavy. We want to avoid that waste is going to interfere with our complete workflow. So if we have a lot of waste here, which generates a lot of weight, it's going to interfere with what is there. Textiles, not necessarily this one, but certain textiles are quite airy. So even if you generate a lot of air movement, they will not be sucked down towards the bed. They will be still very, let's say, very free to move on your working area. If you have those types of materials, well, if you add a waste cut, it will never interfere with the material which is being cut. If you don't do it, it could be that it starts to bunch up, it starts to slightly pull on the material because of its weight. Another thing that is difficult to show is that our de-reeling system also generates no tension on the fabric. So if you look at our de-reeling system, generally there will be a loop running from the de-reeling system, and it will relax that media before it starts to be cut or before it starts to be transported by the machine. So there is a very high, let's say, a high focus on removing any stretch or any stress on that material. So yeah, generally those are two major points for, let's say, cutting with the laser, especially cutting with a vision. It generates the files automatically, or it generates the cut paths automatically. We generate automatically a waste cut. That waste cut, before I forget, can be defined how many times it's going to do. So it's either going to be for every scan, every 2 scans, every 3 scans, every 4 scans. So you have some influence on that. You can even switch it off if you want, but then you need to realize that it could basically be heavy and it could slightly influence what is being cut there. So waste cut, no files needed. Thirdly, the edge sealing and all the interaction you can do with your material is also a benefit. And number 4, the efficiency, that's a difficult word, the efficiency that you generate by being able to cut while you're transporting your material. That's also one of the reasons why we can, let's say, limit the footprint of the machine. If you look at a lot of textile cutters, they generally have a very long bed, and that long bed defines your largest nest. So if you have an 8-meter long bed, you can have an 8-meter long nest to optimize your nesting. On this machine, in theory, you have an infinite length of bed to nest because you're continuously moving your textile, and there is no way of, let's say, of stretching that fabric, and it's continuously scanning, rescanning. It's going to be continuously calculating where everything is. Very important to know here is that all the cuts, because we're not working with files, are going to be cut to the print size. If your printer is going to print 10% bigger than your design, then basically we're going to cut 10% bigger. If you need to, let's say, compensate for that, then we need to have file, then we need to have registration marks, and that's something you can't avoid from that moment. Before that, on this, if you have your complete process under control, you can easily add those black outlines and cut everything. A very common question is, and it's good that I have this design here. So this is a black and white design. Will the vision all of a sudden detect the white in here as a cut? No. Will it detect that black as a cut? No, because the procedures or the methods or the let's say the intelligence in our software is based that it's only looking at the waste. So it's basically generating all the contour cuts on the outside. It will never generate contour cuts on the inside. There is another way to do that, but again, you need to have a file, and again, you need to have registration marks. If you want to have an automatic system, the outlines are perfect, but there's no way that it's going to cut inside. If you have, for instance, a football or a basketball jersey where there is a number, a white number on, or a text on, it will avoid to cut that number because you don't want to have a big, let's say, number cut out in your jersey while you're on the field. It's going to be a bit cool, bit cold if it's going to blow, and it's not going to look good at all. So it's not going to cut inside. Now, going further, let's look at the last part of the video that I shot of this cutting, and I'm going to narrate while it's being cut, because I want to the points that I've mentioned just now, I'm going to point out while on the video. So if we can look at that video. So here again, okay, it's cutting. It's not transporting at the moment because the conveyor will, of course, stop and allow the laser to cut everything before it advances. So on the right, it's just scanned that rear section and it generates the outlines. It was moving forward and it was already cutting using the laser. I set up my, let's say, my workflow that it's going to cut 3 mm on the inside. I could have just set 0 and then it would cut on the outside. Now, what you need to be aware of, while this is running, you need to have somebody in front picking up all the pieces. Otherwise, you need to have boxes arranged before your machine to catch everything. Otherwise, they will drop on the floor. Here you can see the waste cut, and the waste cut is generated from right to left or left to right. It will do this related to the last cut. And it will only cut the waste. It will not cut through your design, of course. It will start outside of your material, go to your first object that was cut, and then skip that, because with the laser you can easily switch on and switch off your laser beam, and that's going to be a very big, let's say, advantage for your speed. Here again, it's going all the way, and it's linking up all these shapes. The additional waste cut has the advantage of not starting to pull on the rest of your material, but then the other advantage is it's going to be a lot easier to get rid of your waste. Because, yeah, if you have a very big piece of waste, it's going to be very unruly to run, to grab everything and go to your disposal box. So as you can see, we just cut some tops. Now we're busy with leggings, and there is one thing you need to consider. There is around about a 1 centimeter distance in between jobs. If you link them up to each other or they connect completely, the vision will not generate a cut path in between two shapes. It's going to, of course, consider that one shape. So you need to have about a 1 centimeter, 10 millimeter white space around your material to, of course, be able to generate a complete contour. And yeah, once you start the system, it will continue until it is at the end of the roll, or until it no longer sees any data. So in software, you can define on an empty scan. So when there is nothing more in the scan, it will stop. You can, for instance, define how many meters you're going to cut. For instance, you're at the end of the shift. You still have about 100 meters to cut, but you only have time for about 20. So you just simply start 20 meters and you just leave the rest for the next morning. That's also possible with our units. So I would, yeah. It always fascinates me, the scanning and then the cutting going in unison, and it's sometimes hypnotic, at least for me. Well, what each shape is, this is backs, fronts, sides, leggings, small pieces that are necessary to link everything up. So yeah, we can continue, but I would suggest that we stop the video and then go to me. So I hope all of this was interesting. That you learned something about it. Remember Vision Trace, which is the black outline around every shape. Vision Trace is something that we're going to use for garments, not for instance, soft signage, because soft signage, that's a completely different industry. Here we're going to use those outlines because it's an automatic system. It's easy to use. The operator simply needs to press scan, cut, and then he just stands in front of the machine, grabbing all the pieces and organizing everything. The unit you see here has a short front conveyor. It could basically be extended, so you have a larger area to pick off. So that's a possible option on here. The laser tube that is in here is a metal tube laser, so a high quality laser tube. At the moment it's a 100 watt air cooled laser. We do offer water cooled lasers as well, but the water cooled lasers are generally higher powered. And if you're not acquainted with the laser technology, the more power you have, the more potential cutting speed you have. But you still need to take into account the limitation of the machine. So the machine itself runs at 1 meter per second. If you're already at 1 meter per second with a 100 watt laser tube, there's no, let's say, there's no reason to upgrade to a higher powered one, because mechanically you're limited to that speed. Of course, if you have a 100 watt laser and you're cutting at, let's say, 250 millimeter per second, there is definitely a big benefit you can get from upgrading your laser power as well. So, let me look at my colleague, Caspar. Yeah, we do have a new colleague, Caspar Vermeyen. I didn't introduce him in the beginning. We used to do an introduction of both ourselves, but he's more than willing to sit behind the cameras. Do we have any questions in the chat? No? Oh my God. Either I was super boring, either I was super clear. But anyhow, if you don't have any questions, you can always contact us through either one of the resellers, through one of our salespeople, or even directly through, let's say, Facebook and YouTube. Don't hesitate if you have if you have questions to contact us. The only thing that's left for me to say is thank you for joining. This stream is recorded and is going to be featured on YouTube as well. So if you want to re-watch it later, you're able to, and it's going to be the raw footage that we're going to put on there. So if there were any delays during the stream, you're not going to have this with the, let's say, the pre-recorded stuff. So I would say stay safe. We're still having a pandemic, so hope to be seeing all of you very soon, either on trade shows, healthy, or on one of the other future webinars. So I would say thank you for watching, see you next time, and stay safe.